In this video, we're going to look at the secant segment product theorem. This theorem says that if we're given a circle on the Euclidean plane and two seconds to this circle, say the secant AC and the secant AD, which intersects the circle at the points B, C, D, and E respectively, then we could actually show that the product of AC and AB is equals to the product of AD and AE. We know that the segment AC and segment AB are on the same secant. And on the right-hand side, the segment AD and segment AE are on the other secant of the circle. So it turns out to be a very interesting product. To prove this relation, what we would need to do is to observe that this relation between two products is in fact equivalent to the following relation between two quotients. AC over AD and AE over AB. This equivalent relation is clear. What you need to do is just like moving the terms around a little bit. And as of how to prove this relation, what we're going to do is going to make use of similarity of triangles. So we would like to join the point E and point C to obtain this chord of the circle, as well as point B and point D to obtain another chord of the circle. Now, by joining those two pairs of points, we would actually form one pair of two triangles. And we're going to show those two triangles are in fact similar to each other. Hence, we would love to show that the angle CAE is in fact the same as the angle DAB. They are precisely this angle down there, the angle CAE is the same as the angle DAB. They are precisely the same angle. On the other hand, we note also that these two angles are inscribed angles of the circle intercepting the same arc. And if we pick a point on this arc, then we could denote that arc as BPE. Then the measure of the angle ACE will have to equal the measure of the arc, or 1/2 the measure of the arc, BPC, which in turn equal the measure of the angle ADB. And the reason being is by the inscribed angle theorem. Inscribed angle theorem. Hence, by the AA condition, the angle condition for similar triangles, we have the triangle ACE similar to the triangle ADB. Consequently, the proportion between the corresponding side will have to be equal. And the side facing the angles C and D in those two triangles are AE and AB respectively, while the side facing the angle ABD and the angle AEC are the side AD and AC respectively. Hence, we conclude the desired relation of the quotient. And that is what we like to prove.